How are you, Ania? Hello, how are you, Ania?
How are you?
Good, good. We're getting to the end of the semester. I know you're excited, right?
Yes.
Go
I have two questions. I have two things, right?
ahead.
So on my Canvas, I had gotten a 70 on test 2, but then it said I only have a 60 in there, so my grade dropped. Like on Pearson, it said I had a 70, but then on Canvas, it said I have a 60.
The 70%, you know, the what do you call it? The Pearson calculate the grade based on percent, but in the Canvas is a point. Let me see.
Yes, so when I did the point conversion on Canvas, it said a 60% instead of a 70%.
Yeah, because it's still 70%, but it now change. The test has how many points again? Let me show you what I mean by this. Okay. 1 minute. Okay. Yeah. Um, yeah. So this is you here, right? For the test. Is it test 2 or test 1?
Test 2.
Test 2. Can you see the screen?
No, I only see you.
Oh. Let's see if I can share it. Yeah, am I opened yours. So I'm here. Let me move this away. Okay, plug all these names. Right. Look at this. This is test. Is it test 2 or test 1?
Test 2.
Yeah, test 2 is not really showing here, but I'm gonna see why. I see test 1. I don't see test 2 here. So I'm gonna go direct to the test. So
it says it right there, not on the side, but it says it in the middle, right directly in the middle. Test 2, 18 out of 30.
Yeah, okay, good. Right here. That's it right here, right? Number 30. Now, if you have you see what was a grade you have in Canvas, I mean Pearson?
In Pearson, let me go look right now.
Yeah. Or I can look it up. I can look it up myself. So let me pull it out. You know what, Ania?
Yes.
Let me see how much time. Let us do this after the class because it might take it. So we have more time then. Okay.
Okay. And I'm just saying, like in Pearson right now, it says I have a 70.39.
It's 70 point what again?
30, but 70.93.
Let's say that I will check it myself, though, but let me use what you just told me. But I will check it myself.
Okay.
So we look at, and that test is 30 points. Okay. So what you're gonna do is this is how you calculate it. This is the calculator. You say 70.39%, right?
70.93%.
0.7093 times 30 points. So it's 21.279.
21.8, yes. I mean 21.28.
Yeah, which is 21.28, yes. Yeah. So, and in that test, what did I put there?
18.
I put 18. That means it's a mistake. So what will happen is this. After the class, I will double check it again, go to Pearson, see the grade myself, and then correct. If it's a mistake, and then I correct it, okay?
Okay. And then the other thing is, do you think I can you open up this last homework that was due? Because I had some family stuff come up and I wasn't able to complete it last night.
Yeah, that one remind me after class so I can do it right away.
No problem.
Yeah. So, yeah. After the class, we'll take care of all this. So let us, I think we can now begin. I want to close some pages. I opened too many pages. So I'm going to close Morgan page, log out and close it. All right, we have it here. On Friday, I introduced you to the test of hypothesis, and I gave you I explained how to state hypothesis. Today, we'll be working on actual hypothesis testing. But before that, I want to show you something, more terms that were used in hypothesis testing. The first one we have done this before when we are doing confidence interval. Okay, the level of significance simply is it tells us the probability of rejecting the null hypothesis when it is true. So rejecting a correct null hypothesis is the level of significance give us how, help us to calculate that. For example, if we say that normally we use alpha to present significance level. So if the alpha is, let's say 5%, that means you have 5% chance of being wrong or of rejecting a correct null hypothesis. That is rejecting it when it is true. So that your chances of being wrong is 5%. If it is 1%, then it's a chance of being wrong is 1%. And I also showed you how to use that alpha level to calculate the critical value for confidence intervals. So confidence interval have two sides. So the same method you use to calculate the critical value for confidence interval, you also use that method to calculate the critical value for statistical tests, so long as they are two tails. And I'm going to explain what I mean by two tails in a minute. So the probability of committing type 1 error is what we call the significance level. And we use alpha to, to denote it. Next thing is the critical level, the critical region. Critical region is the region where we use to reject or not reject a hypothesis. I explained more an alternative hypothesis to you last time in my last lecture. So if our answer falls within the critical region, we reject no hypothesis. If it does not, then we don't reject. So let me explain more. Normally we have two types of tests. We have two-tailed tests, which is like the confidence interval. That means the critical region is in two sides. Now we have one-tailed test where the critical region is only in one side. It can be on the left tail or it can be on the right tail. So let me draw this to show you more what I mean by that. For two-tailed test. So I have it in this form. Okay, we have smart shapes. Okay. Now we have our horizontal axis here, and of course the mean. Okay, which is 0, usually 0. Okay. Now we have two sides that should be shaded to present the critical region. The left side and the right side. So let us share the two sides. So you can see that the two sides we are shaded. Okay. The shading is the difficult part. It's usually better usually easier when you are doing it on paper, handwritten method, or drawing it on a board. For drawing it on the computer screen, word like this is you have to be good with how to use words. But we're not being bad, Oh, excuse me. Okay. Now we have this one. Okay. Now we have this. All right. So we have two-tailed test. Why do we call it two-tailed? Because it has two sides. Two sides are shaded for the critical region. Yeah, it has two critical regions. Okay. Right. So we have the critical region. Critical region. Or I can call it the rejection region. Okay. Critical region. You guys can see this, right?
Yes.
Okay. I'll make sure this is good. Critical region. Now, the critical region, like I said, are the rejection region. So if our answer falls here or in this shaded region, starting from this point here or from this point on the left down. So if our answer falls there, okay, you reject. This is what is if our answer is here. This one is acceptance region. Acceptance. Okay. Acceptance region. So if your answer for here, starting from this point. Now, this point, this beginning, this borderline is what we call the critical value. And this one is also the critical value. So because it is here, if any answer falls here, you reject. If it falls here, you reject. So for this type of test, this is how we state the hypothesis. HO, you say that the mean is equal to some value, any value that the parameter can take. I don't see the equal sign here. Okay, let me just use mean equal to k. K can be any value of the statistic parameter you're testing. And H1 will be mean not equal to k. So whenever you see equal and not equal to, you know that it is a two-tailed test. Okay. Now, for one-tailed test, this one type, where we have only one critical region, in that case, it might look like this. I can draw another one. Okay. Right. So we go from here. Okay. And then we can now complete this one. Okay. Just give me 1 minute. I want to do something here. This is let me use left tail, one tail test. But this time it's on the left tail. If it's on the right, it's called a right tail test. Okay. So if the critical region is on the right. So in that case, you have it here. Okay. Now, the middle, and then got got this left third. So you have only one critical region on the left third. That's why we call it a 1/3 test. And because the critical region is on the left third, we call it left third test. Okay. So in that case, it's gonna be one will be less than one. Of course, like I explained last time, the null hypothesis have to be used at some kind of equality, you know. But the alternative can be any other thing. So this is where the rejection region is. Critical value or critical region. So in that case, you will have it here. Only one critical region. Okay. So for this to state the hypothesis, you have HO. You can say mean, and then H1 and H1. Now it's on the left side. You call it left tail test or 1/3 test. If this is on the right side, you call it right tail test. So it's on the left side. That means it's gonna be less than here. H1 would be mean is less than mean is less than because on the left side. Okay. Now this will be the opposite of H1. So that case mean is supposed to be put greater than here, but because you cannot use greater than on this side for the null hypothesis, so we're gonna use greater than or equal to k, where k can be any value for the parameter you're testing. So if we repeat this diagram and put this region on the right side, in that case, it will be right tail test, which means that here will be mean will become greater than k, and this will be less than or equal to k. So that's basically what it is. So let's see. Now, if your answer fall in this region, reject. Now, your answer falling in the critical region is the same thing as saying that your answer is bigger than the critical value. This is the critical value right here. So it means that the answer is equal to or bigger than the critical value, you reject. If your answer is less than the critical value, you do not reject. So that's what that's basically what it is. Here, if your answer is less than negative, for the 2/3 test, the answer can be if your answer is positive, that means your attention will be on the right third. If the answer is negative value, you go on the right. So that's why we use plus or minus for a 2/3 test. So if your answer is bigger or equal to the critical value, it is something as saying that the answer fell in the critical region, which is the rejection region. So let us example will clarify this more. So let's look at the methods. The first method we try is the traditional method of testing hypothesis for the mean, and we're gonna use the z-test for the mean. The working rule are as follows. We have the excuse me, 17. State null hypothesis and identify a claim. Find the critical values for the from the appropriate table. Compute the test value. Test value is the same as saying test statistic. Then make your decision to reject or not to reject null hypothesis. And then this is the decision criteria. You reject the null hypothesis if and only if the calculated answer, here's the answer, is bigger than the critical value. So when it is bigger than the critical value, it means that it fell in the rejection region. So this is the formula here, z equals x bar minus mean over standard deviation over root n, where x bar is the sample mean, population mean for mu, delta is for population standard deviation, and n is the sample size. So let's try one example here. Let's try one 1-tailed test and then a 2-tailed test. Okay, so tomorrow we'll start to repeat the same process using the p-value method. And this one it says a researcher. Make sure you're seeing this. Okay. A researcher reported the average annual salary of professors, assistant professors in the year 1997 is more than $42,000 a year. A sample of 30 assistant professors have a mean salary of $43,000. At alpha 0.05, test the claim that assistant professors earn more than $42,000 a year in 1997. The standard deviation of the population is 5,230. Now, somebody who is reading this might say, you are saying that the average salary is 43,000. And this, for this sample of 30, the average is 43, sorry. He might say that, he or she might say that the average salary is 42,000. But a sample of 30 assistant professors show that the average is 43,000. So that means there's no need for the test, since this one is bigger than that. No, there is a need for the test. Remember, this is only a sample of assistant, 30 of them. But we have hundreds of thousands of assistant professors in America. So that means you need the test. This one is only for a sample, a small sample. See? So that means we have to make the test so that we can now generalize our answer for all assistant professors in the year 1997. See? So the first thing, remember the first step, it says state the hypothesis and identify a claim. Okay. Let us first of all state the hypothesis. Solution. Yeah. You say that the research report that the average annual salary of assistant professor in the year 1997 is more than is the key word here. So more than 42,000. Here, our care is 42,000. Remember, we said here that near equals to, not equal to care. This time, our care is the 42,000. So we have HO and the H1. H1. Now, more than means greater than. That will automatically tells you that it will be in the alternative hypothesis, because it's a more than. If it says greater than or equal to, in that case, it's going to be in the null hypothesis. But it's a more than, that means greater than, should be in the alternative hypothesis. So that we have it in this form. Mean the average salary is more than, which is greater than 42,000. That's what the study is claiming. That is the claim. So that the null will be the opposite of that. So our null will be, okay. Oh, by the way, our exam date, I'll announce the exam date, final exam date by tomorrow evening. I'll post an announcement to tell you the day for the final exam. Final exam will just be like a regular test exam. It will be 10 questions. I pick one question from each topic we covered. So there's no need to panic here, because it's what you already learned. So you complete it in my lab, Pearson, my lab, like you normally complete assignment every week. That's it. Then submit your project, and then the other second discussion question, Anyway, so the null is always the opposite of the alternative. So you're gonna be mean. Mean is so you're gonna, since it's less than, since it's greater than, more than, here you're gonna be less than for the null. But because you cannot use less than symbol in the null hypothesis, so we're gonna use less than or equal to. Less than or equal to 42,000. Okay. Now we have done the first step. The second step says find the critical values from the table. Now our alpha, the significant length they give us alpha is 0.05. They give us as the alpha. Okay. 0.05 is the alpha. So that the critical value will now be, get it from the table. Now, if it, because this is greater than, means that it is the right tail test. Greater than means that it is on the right tail. So let me show you how the chart will looks like. You know, let me show you here. Okay, my mistake. I gotta put this. The chart will look like this. Okay. Okay. Now I'm gonna put this. Okay. Then this. So this is the chart, and then you're gonna have the, because you're gonna be on the right there, so you're gonna be somewhere here. Why do I say it right there? Because it says greater than. So now if you say less is, if you say less than, then it will be on the left there. So now we can find our critical value. Critical value will be the value on this line. The value on this line will be our critical value. It is the cutoff value. Once you equal to that value or more than that value, you reject null hypothesis. But once you are smaller than that value, then you do not reject null hypothesis. Okay. So let's find our critical value now. Z critical. Oh, I think I'm gonna move this a little bit. And this is 0 here. You know what? I'm gonna put it right here. Let me move this up a little bit, down a little bit. Just 1 minute, everything should be fine. Okay. Just 1 minute. I figured it out. Okay. Okay. All right. So that the shading will be uniform. One more. Okay. All right. So that this is our 0 mean. So the critical value. So now let's find the critical value. Z critical. Now, because of the fact that it is 1/3, we're not gonna use. Remember, when we're doing normal distribution, I explained that when the area fall in the tail, you subtract your answer from 0.5, provided you are using this kind of table I gave you, the table of normal distribution. So if you're using a different kind of table, that the one that is cumulative, then you're gonna use a different approach. But like I said, I recommend this one because that's the one we're using here. So based on that, our critical value is Z critical. Z critical, ZC will be 0.5 minus, they told you that the alpha is, okay, let's see. We can't get it now until we get our Z value. So let me leave it the way it is. Now, so find the critical value from the table. The critical value from the table. So yes, we have Z critical. They give us alpha as 0.05. So we're gonna do 0.05 equal. Let's just find it. It doesn't matter. Okay. Control plus. So this gives us 0.5 minus 0.05. I got 0.5 from this mouse. 0.5 minus 0.05. He gave me the answer of 0.45. So which is 0.4500. 0.4500. Why did I add 00? Because that table that I just showed you, it has 4 figures, 4 numbers. So because we don't have the fourth number here, and we use 2 zeros as the place value. Now we go to that table and look for this number in that table. If you don't see this number, we use the one that is closest to it. So when we go there, at that table to look for the number 0.45, as we see 0.4495 and 0.4505. Both of them are equally close, because if you have 0.4500, 0.4495, 0.4500 minus 0.4495, I'm going to show you. 0.45 minus 0.4495. See, the answer is let me use them as whole number. So 4500 minus 4495 will give me 5 points away. Now, if you repeat the process using the other number we have there, this one here, I'll have 4505. You have 4505. Okay. So that we have 4505 minus 4500. See, it's also 5 points. So both of them are equally close. Now, if you look for the number, if you don't see the number exactly, we use the one that is closest to it. But if we find two of them that are equally close, you choose the bigger number, which is this one. So when you follow it to the left, you see that it is 1.6. And when you follow it up, 5. So it's 1.65. 1.65. So 1.65. 1.65. Oh, excuse me. 1.65. Now, because the critical value is on the right side, it becomes the critical region is on the right side, it becomes positive 1.65. If this critical region is on the left side, it's going to be negative 1.65. So that is our critical value. So we have stated our hypothesis, then we have found our critical value. Next thing we need to do now is, according to the steps, says to compute the test statistic. Now, the test statistics, as you know, is the formula is here. Z equals to X bar minus mean divided by standard deviation over root n. So let us put numbers in, and then we can now calculate them. So I'm going to write down S bar. Now, a sample of 30 assistant professors has a mean of salary of 43,260. That is our X bar right there. So let me write it down. X bar is 43,260. And then the standard deviation, delta is, say the standard deviation is 5,230. Is 5,230, okay? And the sample size is a sample of 30 assistant professors. So sample size n equals 30. And then the population mean is 42,000 for the entire population. So mean is 42,000. Now I'm going to put all these numbers in so you can see what I'm talking about. First of all, they say that there is such a report that the average annual salary for all assistant professors in 1997 is more than 42,000. That is the population mean right there. That's this one. Okay. So I'm going to put it right there. I have mean equals 42,000. Then the standard deviation they give us is 5230. So standard deviation is 5230. The sample size is they use the sample of 30 assistant professors. So N equals 30. Now, out of these 30 assistant professors, the mean for that is 43,260. That's a sample mean. But since we don't have that character for sample mean here, I'm going to get it from the other workbook and paste it here. So I'm going to take you there so that you can get it. The sample mean X bar equals 43,260. So all these things we plug them in, okay, into our formula to get the test statistics. So I'm gonna make this a little bit bigger. Then make this ones bigger as well. So once you leave them like this, it becomes more easy. So let us plug these numbers into the test statistic formula, this one here. So I'm gonna take you there to the other formula, other page, so that we can put them in. We have Z equals, have S bar is sample mean, which is 43,260, minus population mean of 42,000, divided by standard deviation of 5230, by the square root of N, and our N is a sample of 30 assistant professors. So now let us evaluate this and then put the answer in. So we have this in a calculator. We have okay, this is the calculator right here. So it was 43,260 minus 42,000, okay, divided by standard deviation of 5230 over square root of 30. Okay. Let me check something here. Okay. Anyway. Okay. So that gives us 1.31956, which is approximately 1.32. So we go and put this in our work. Formula 1.32, and then copy the entire result to this place. Our main workbook. Okay, just here. All right. So we have run the test to get the result. Remember that our critical value was 1.65, which is right here. Value 1.65. So this is the line that represents the critical value. The whole of this place is the critical region. So if your answer is 4 in this region, this value, or more than that, that means if the answer is bigger than this, we reject more hypothesis. So now we have run the test. This is the result of our test. Now let us make our decision. Okay, decision here. Let's make it the decision time. Okay, make this bigger. So now, the critical value, this critical value, yeah, ZC equals, answer we got for critical value is 1.65, which is right here, 1.65. 1.65. Okay. Oh, excuse me. This is a decision time. Okay. Now, the calculated value, our calculated answer, calculated value, calculated z value was, and we got 1.32. 1.32. Now we compare them. Is our answer bigger than this? If our answer is bigger than this, that means it fell in this rejection region. So if the answer is bigger than this, we reject. But if the answer is smaller than the critical value, we don't reject. So the answer becomes, do not reject the null hypothesis because 1.32 is our answer is less than the critical value. That means it fell in the acceptance region. Okay. So it's less than the critical value. Critical value of 1.65. See? So that's our decision. Do not reject. Remember, the null hypothesis was that the salary is less than or equal to 42,000, but the claim is that it's bigger than that. So this is the claim. Because we did not reject this, that means the claim is not correct. So if you are accepting this, that means the claim is not correct. So our conclusion become there is insufficient. The claim is incorrect, or you can write that, or there is insufficient evidence to support the claim that the salaries of the assistant professors okay, in 1997 is more than 42,000. Any question for this? Any question on this, class?
No, not for me.
Okay. So the same method we use, that's the same method we use for two-tails, except that here we're gonna use equal sign and not equal sign. The same now the critical value for two-tail, you use the same method you use for critical value for confidence interval, P over 200, and then get the answer from the table. So like now, if you look at this one, how do you know it's a two-tail test? If you look at this one, let me get this one here. It says the Medical Rehabilitation Foundation, Education Foundation report that the average cost of rehabilitation for stroke victims is 24,620. This is, you see the keyword here, is, mean that it is equal. That means the null hypothesis. So in this case, the null and alternative will be solution. Okay. The null and alternative are going to have H1, HO, and H1. Okay. H1. Now we have these two. Now it's a is means equal, and you know that equal sign is used only in the null hypothesis. So that means mean is equal. That will tell you that the claim is in the null hypothesis. Mean equals 42,000. I mean 24,672, and the alternative will be mean not equal to not equal to 24,000. Excuse me, just class. Hello, Oliver. Hey, guys. Can plug in a few minutes. I'm in my class. Oh, I don't know. I'm accusing online. Okay. Now, remote. All right. Just a minute. 24,672. So now, you see, sorry about the interruption, class. It was my emergency call. To see if the average cost of rehabilitation is at a particular hospital is the researcher select a random sample of 35 stroke victims. So now, remember, it is saying that a report that the average cost is 24,000. So you can see that the claim is sure that the claim is here, because is means equal sign. Now, once you have it in this form, now you get a critical value. Value C, ZC. Now, because this is a two-tailed test, you can just do P over 200. Why 200? Because it's two sides. I showed you the diagram for two-tailed test here, where the critical region is on two sides, left side and right side. So that's why we use about 200. Now, it said that to use alpha of 0.01, which is your chance of being wrong is 1%. So you get at the 99%. So that our P over 200 becomes 99 over 200. This is just one way of getting it. Okay. So 99 over 200, we have 99. Okay, 99 divided by 200. 0.4950. So 0.495. 0.4950. 0.4950. Now, you can now look for this on the table of normal distribution. You can go to the table here, 0.4950, I think. So 0.4950, see, for 0.4950, you see 0.4949 and 0.4951. See, both of them are equally close. So use the bigger one, which is 0.4951. If you follow it to the left, 2.5, okay, up 8, which is 2.58. 2.58. Now, because it is a two-tailed test, you're going to write it as plus or minus 2.58, just in case your answer falls on the left side. And I think I showed you how 99% critical value for two-tailed test. I think I once mentioned it. Okay, let me see what is wrong here. Okay. I don't know why it keeps showing us this, but okay, good. I think I showed you somewhere here where they wrote all the critical values. For 99, you can see for 99, so you can see that it's 2.58. Yeah, I just showed you that. So once you get it, all you have to do next is to, now you have your critical values. You just follow the same step we did here. You list the mean, standard deviation, and then run the test. In our own case, the mean is, let me draw this chart. Gonna be the mean is, let me give you the chart first. The mean will be here. The chart will be like this. Okay. Oops, I messed up. Okay, let me draw it again. I know our time is up, but this is important. Let us just finish this one and we'll be good to go. Okay. Then, because it's these two sides, you're gonna be put shaded on two sides. I'm gonna shed on the left side. I'm gonna shed on the right side. Okay. So we're gonna shed here. Okay. This and that. Okay. All right. Just exercise patience. We'll soon be done with this. Okay. I know some of you are going to work. We'll be very soon be done. Okay, I have. So it's 2 tails. This is how 2 tails looks like. Okay. This one here. Okay. All right, all right. Last one. So since our critical value is plus or minus 2.58, that means for the left side, it's going to be, I think I'm gonna move this a little bit down. Okay. Left side is gonna be negative 2.58, and the right side will be positive 2.58. Okay. Now we can now list the values. Now to do that, let's look at the question again. It says the Medical Rehabilitation Education Foundation report that the average cost of rehabilitation for stroke victims is 24,672. So that means for all stroke victims. So we have it at as the mean equals, okay, equals, let me write it down so I can put them easily. Mean equals 24,672. So 24,672. Then now to see if the average cost of rehabilitation is different, it didn't say greater than or equal, it says different. At a particular hospital, a researcher selects a random sample of 35 stroke victims. So our N is 35, which means our N is 35. For this sample of 35 stroke victims, he found that the average cost was 25,226. So the sample mean 25,226. Now, because we don't have the character for sample mean on this workbook, I'm gonna get it from the other workbook, okay? And put it right here, back here. I'll have X bar equals 25,226. Okay, 25,226. Put right there. So you can see it's here. And then it says the standard deviation for the population is 3,251. So standard deviation is 3,251. So okay, the standard deviation symbol is here as equals 3,251. Symbol change, correct it. the correct symbol. Now, I'm going to make all this big so that you can see it very clearly. So that we can run let us run the test now. So we plug these numbers to run the test to see if we can reject or not reject the claim. Okay. Now, remember the formula. It says z equals to x bar minus mean divided by standard deviation over square root of n. So we can just go and plug them in and then get the answer from the calculator and then make our decision to reject or not to reject. So let me take you to that workbook so that we can do it. So you have our z equals sample mean of 25,226 minus population mean of 24,672 divided by standard deviation of 32 to 1 over the square root of 35 samples, 35 full victims. So we're going to get this from the calculator. So let me write it down. Okay, I think I have it. Yeah. So we'll go there and put it on the calculator. So we got sample mean of 25,226 minus population mean of 24,672. Okay, divided by standard deviation of 3251, 3251 over the square root of n. Our n is 35. Okay, that gives us 1.008153. So we just round to 2 decimal places, which is 1.01. 1.01 right here. 1.01. Okay, so let us put this in our main workbook, and we have run the test, and the test result gave us the answer of 1.01 right here. I put the result right here. So it is time to make our decision. Like I explained to you, if your answer is bigger than the critical value, then you reject the null hypothesis. If it is less than the critical value, do not reject. The critical value is ZC. ZC, we got it as 2.58, which is what we have at 2.58. 2.58, and the calculated value, yeah, this is the answer we have for our test. Calculated value equals 1.01. Now, again, because the calculated value is less than the critical value, we don't reject null hypothesis. So now, but if the answer is bigger than the critical value, you reject. So as I say, do not reject the null hypothesis, because 1.01 is less than the critical value of 2.58. So our conclusion will now become now remember, we did not reject null hypothesis, and this is where that's where the claim is located. So you can say that the claim is correct. The claim is correct, or you can write that there is insufficient, or there is sufficient evidence. There is sufficient evidence to support the claim. Okay. So that is basically what it is to test hypothesis, the traditional method. You state the hypothesis, identify a claim, get a critical value, then run the test, then compare your answer to the critical value. If your answer is bigger, reject my hypothesis. If it's not, don't reject. Questions? Any question, guys?
No.
Let me just take down your attendance and then you can leave. If any other person have question for me, then they can stay back and ask. It's 5-3-21. The names I'm seeing here on the screen, I got 3 people here. Ania is here. Aaron is here. And Bennett is here. All right. I see you guys on Wednesday when we do my examples. Okay.
All right. Have a good one.
You too.
Yeah. Okay. Do you need me to stay to talk about what we were still talking about?
Yeah. So let us fix the problem. I'm gonna take you there so I can check it myself. This is about test 2, right? Ania, right? I'll take you there. Just give me 1 minute. Let me close some pages so we can have enough room here. Okay, I'm gonna close. Okay, this one is good. Now, what other page I want to close? I think I need to open a new page. All right. Okay, Morgan. So I'm gonna share this with you. So login. Okay. You can see the screen, right? And Ania.
I'm right here.
You can see the screen, right?
Yes.
Good. Let me see where you are located. Okay. That's you right here. So you see test 2, right?
Yes.
Can you see it? A grade here. Can you see the grades?
Yes, I can see it.
So it's 70. So it's gonna be 0.7093. Okay. Now I'm gonna multiply it and update. Okay. First of all, let me look at that test in Canvas. That is Morgan. Okay. Okay, let me share this part. So this is the grade book. Okay, I need a Townsend. Okay, now test 2. Okay, 30 points. So I got 30 points on that. .7093 times 30 points at 21.3. Can you see that?
Yes.
So I'm going to 21.3. Let's see, 21.3.
Is it 21.3 or 21 point? Oh, okay, never mind. Got it.
Yeah, can you see it?
Yeah.
So 21.3. So let me go and update it right away. So this is for test 2. Okay, for Ania Townsend. Okay, test 2. Okay, I think I passed it.
It was by the front. You didn't have to scroll, it was there.
Huh? At the front, right?
Yeah.
Yeah, I missed it. Well, it's right here. 21.3. So,
yes.
Done.
And then can I have an extension on the homework that was due last night? I had a family mishap that come up and I wasn't able to complete it.
I can make it due Wednesday.
Okay.
That was what homework was due last night, I think.
I'm not sure. I don't remember. Oh, it was the confidence interval, the top one.
Homework 11.
Yeah.
Okay. Let me see. All right. Homework 11 and okay. No, manage list. But I'm on the wrong one. So let me take you to the right one.
Okay, so I have to go to work. So do I have to be on here while you do this, or can I log out and it'll be done?
No, go ahead. You're
Okay.
done.
Have a good one.
You too. And the class.